climate? What is weather? Is there a difference between the terms climate and weather? Let's watch the video and find out.
Climate and weather. Together, they are among the most influential forces on Earth. One can influence where and how we choose to live. The other often determines what we do, where we go, and what we wear each day. Climate refers to the average weather conditions of a place over a long period of time. The Earth has 6 main climate zones. Some are mild and inviting, like the Mediterranean climate of southern Europe. Others are harsh, like the arid deserts of northern Africa and the frozen tundra of Greenland. Through history, climate has often played a part in where people have chosen to settle. In the ancient world, some of the first permanent human communities occurred in places with hospitable climates. But humans have long had an amazing capacity to cope with more severe and challenging climates. Today, with widespread use of refrigeration for foods and of air conditioning and heating for homes, humans can survive in all climates, including the frozen desert of Antarctica or the blazing heat of Death Valley, California, where temperatures can soar above 130 degrees. Weather, on the other hand, refers to the day-to-day conditions of the Earth's atmosphere at a particular place and time. Weather can be glorious or annoying. It can also be devastating. Severe weather can destroy homes and property, cripple transportation, ruin crops, and create havoc for people caught in its path. In the United States, weather causes, on average, more than $11.4 billion in damages each year. About 15% of that damage occurs in Florida alone, a state that sees more than its share of hurricanes, floods, and tornadoes. An accurate weather forecast can make it possible for people to prepare for severe conditions before they strike. In cases of hurricanes, tornadoes, and floods, a warning can save lives by giving people time to get out of harm's way. With so much at stake, atmospheric scientists, called meteorologists, are working with new technologies to find better ways to forecast the weather. Powerful computers process atmospheric information to create weather maps and models. Radars track storms on the move and can detect rain up to 250 miles away. Weather satellites look down on the Earth from space, monitoring everything from cloud cover and precipitation to lightning strikes and fluctuations in the temperature of the oceans. There are even research planes that fly into hurricanes to help scientists learn about the inner workings of some of the planet's deadliest storms. In some cases, the study of meteorology can be a nail-biting adventure, as scientists risk their lives to study tornadoes and other dangerous weather phenomena. As scientists continue to study weather patterns and behavior, we can expect to find more ways to predict its course. And the next time severe weather strikes, perhaps we'll be ready.
The video defines climate as the average weather for a given area. The National Weather Service uses temperature highs and lows and precipitation measures for the past 30 years to compile the average weather for any given area. Atmospheric scientists, however, consider average weather to be an inadequate definition for an area's climate. A more accurate definition might include the area's weather variations, patterns, and extremes. Therefore, the climate of an area is the sum of all statistical weather. Okay, so what is weather? The video defines weather as the current atmospheric conditions. This includes temperature, rainfall, wind, and humidity. Weather is what is happening right now or likely to happen tomorrow or in the very near future. Let's continue this lesson by focusing on 2 of the factors that determine weather. These 2 factors are temperature and pressure. Temperature is a measure of energy or heat. One way to determine the temperature is by using your sense of touch. Objects with more energy will be warm or hot to the touch. Things with less energy will be cool or cold to the touch. However, a more accurate way to measure temperature is by using a thermometer. A thermometer often consists of a narrow glass tube. At one end of the thermometer, there is a bulb that contains liquid mercury or alcohol. The liquid expands and contracts in the tube. As a result, when there is an increase in heat, the liquid inside the bulb expands or rises inside the tube. A decrease in heat lets the liquid contract, moving the liquid down the tube. The measuring scale, either marked on the tube or attached to the tube, as is the case in our picture, provides an accurate measurement of the heat energy. On a windy day, why does the outside temperature feel colder than what the thermometer says it is? Most likely, the thermometer is in perfect working order. Instead, it is the wind chill that is making it feel colder than it really is. You ask, how is this possible? When the wind blows across your skin, your body loses heat through the process of evaporation. As a result of losing body heat, the temperature feels colder than it really is. As winds increase, heat is carried away from the body at a faster rate, driving down both the skin temperature and eventually the internal body temperature. Exposures to low wind chills can be life-threatening to both humans and animals. Scientists have developed a wind chill chart, or index, to let you know if the combination of cold temperatures and winds are dangerous. Wind chill numbers lower than -18 degrees Fahrenheit are very dangerous because a person's skin can become frozen within 30 minutes or less. Frozen skin is also referred to as frostbite. A temperature of -5 degrees Fahrenheit with a wind speed of 35 miles per hour creates a wind chill number of -34 degrees Fahrenheit. This wind chill can cause frostbite to occur within 10 minutes. On a hot summer day, have you ever noticed that it feels hotter than it really is? Again, your thermometer is most likely working just fine. Instead, there might be a lot of moisture or humidity in the air. The excess moisture in the air prevents the cooling effect felt from evaporation. As a result, our body temperature can be too high, and this can also be dangerous. The heat index can help us decide if temperature and humidity levels are too dangerous for outdoor activity. Say, for example, that the current temperature is 96 degrees Fahrenheit, combined with the 50% relative humidity. This combination gives a heat index of 108 degrees Fahrenheit. At these conditions, heat exhaustion is possible with too much physical activity. Or, according to the heat index, prolonged exposure or strenuous activity under these conditions is dangerous. Another factor which determines the weather is pressure. The air we breathe is actually a collection of gases that surround the Earth. We refer to this collection of gases as the Earth's atmosphere. The Earth's atmosphere is primarily composed of nitrogen, oxygen, and carbon dioxide gases. The weight of all this air pushing down on us is what's known as air pressure. The more air that is above us, the higher the air pressure. At sea level, the average air pressure is about 101 kilopascals. At greater heights like Mount Everest, the air pressure is lower because there's less air above pushing down on us. If you stand on top of Mount Everest, which is over 29,000 feet above sea level, the air pressure is only about 30% of sea level air pressure, or 31 kilopascals. Temperature can also cause air pressure to change. Warm weather rises, resulting in lower pressure. On the other hand, cold air will sink, making the air pressure higher. In weather forecasts, this is where the terms low pressure and high pressure come from. A general rule of weather forecasting is that when a low pressure moves in, it will bring lousy weather. On the other hand, high pressures bring in happy weather. Winds are the result of air constantly moving around the Earth. Winds are created when there are differences in air pressure from one area to another. In areas of high pressure, air at the ground level spreads out, moving away from the high pressure. In an area where there is low pressure, air at the ground level come into the center of the low pressure to replace the air that is rising. This is what makes air move, thus creating the wind. To help you remember this, say, the air will blow from high to low. When a high and low pressure area are close to each other, A strong wind will develop because a natural circulation of air will occur. The greater the difference in pressure, the stronger the wind. This concludes this unit on climate and weather. Thanks for watching.